Hello, good evening all. Am I audible?
Yes, ma'am.
Okay. So, so, is there any doubt in the previous assignments? Are you able to solve the weekly assignments that are given? If there is any doubt in the previous assignment, please let me know. Okay, let's start with the week 6 assignment discussions. I have few questions. I hope you have watched the lectures related to the week 6. So I will be sharing my screen. I have some questions based on the concepts that are covered in the week 6 lectures. So today we will look at them to know how well you are with the concepts. So, okay, so let us start. My screen is visible as well, right? Please confirm.
Yes, ma'am.
Okay, okay. Just a second. I will. There are some people who are willing to join. We will start shortly. Just a second. Okay. So let us start with week 6 assignment. So today is the live session 6 and we will be discussing the questions related to the content covered in the week 6 lectures. So this is the first question. I'll give you 2 minutes to mark the correct options and you have to tell me like which are the correct options. Put your answers in the chat box once you have solved it. We will discuss it shortly. I'll give you 2 minutes to solve this question. This is a very easy one. This is covered in the week 6 first lecture. So they are asking about some points related to the dependency structure. What is the relation between the head and the dependent? And you have to tell the correct options. Here, more than one option can be correct. Okay. MCQ. Multiple option correct. So please let me know once you've solved it. Put your answers in the chat box. Any answers? A and D, A and C. Okay. Any other? Only two people were able to solve this question. Vidya and Siddharth. What about others? I can see 11 people are there. Please put your answers in the chat box. A and C. Okay. Why not D, Sonali? Okay. I will begin with the discussion. So here they are asking about the how do we construct this dependent. You're not sure about option D. Okay. No issue. So here they have given the dependency structure and they are asking what are the valid criterias for the syntactic relation between the head and the dependent in a construction C. So construction of C here, C construction by means it refers to the construction of this dependency structure, and they ask the relation between the head and the dependent. So they ask like whether the form of D depends on H. What is D here? D is the dependent and H is the head. So obviously the form of D does depend upon H, because as we can see from the name itself, dependent. So this D is always dependent on head. So this is obviously correct, first option. Okay. I don't, just a second. And H gives the semantic specification of C. So since this head is the one which helps us to know how the grammar will be constructed, what all words are dependent on it. So how can we understand this head and the dependent here? Let's say there is this John saw Mary. So if we try to construct a dependency parse between them, like what word is dependent on what, we know that John and Mary are nouns and the saw is a verb. But if we see for this saw, what is the object? What is the subject here? John is the subject. And what is the object? Mary is the object. So this English language, it follows this word order of construction like subject, verb and object. And what here we can since we can see like saw is the one, saw is the main construct here, and the and this John and Mary they depend upon it, so saw can be called as the head and John and Mary can be called as the dependents. Okay, so we can see the form of D does depend upon H, who saw whom, so that is entirely dependent upon this head, and H gives the semantic specification of C. Semantic by here refers to the meaning. So if there is this no John and if there is no John and Mary, if there are other names as well, that can be fine. But this saw helps us to identify what this sentence indicates. Who saw whom? It gives meaning. It renders meaning to this sentence. So H gives the semantic specification of C. This is also correct. D selects H and determines whether H is obligatory. No, D does not select H. Rather, H selects the D and determines whether this obligatory, whether it's allowed or not, or that way. So this option is wrong. D does not select H. D is determined by H. D cannot select H. D specifies H. Yes. D will help us to give more specification of H. H is your head here, so this determiner gives more specification, like it specifies who saw whom. So this D specifies H. This is also correct. So the correct answer here is A, B, and D. So This is your correct answer. Please let me know in case anyone has any doubts. So some people were saying option C. Option C is not correct. I hope now it is clear why. So any doubts, please let me know in this current explanation if there is any doubt or any point or any option you didn't get. Because questions like this only you will see in your assignments that are being given to you for this week. So you have to take this kind of analogy to eliminate and identify the correct options. Is it clear to all? Shall we move to the next question? Okay. So this is the second question. Here you have been given two different words and the relation between them, and you have to tell whether that is endocentric or exocentric. So again, an easy one. I'll give you 2 to 3 minutes to solve this and put your answers in the chat box. And in this case, now it is only single option correct. Only one option is correct out of the four. So please give it a try. I will discuss it shortly. You first remember what is the definition of endo and exocentric and how you can apply it to this A and B to identify the relation between them. I'll give you 2 minutes to solve this question. Please, everyone, give a try. It will help to know whether we are getting thorough with the concepts discussed in the lecture or not. And please put your answers in the chat box once you have attempted it. D. Okay. What about others? Please give it a try. You have to apply the definition of endo and exocentric over here. So what is exocentric? Anyone? Please unmute and answer. Let us be as interactive as possible. What is meant by exocentric? Please unmute and answer. Am I audible? Can you hear me? Then please unmute and answer what is exocentric and endocentric. We cannot hear you. So in case of an exocentric, it is the case that as we saw in the lecture, a single entity, it cannot fulfill the grammatical construction of the entire sentence. Whereas in case of endo, it's opposite. A single entity does fulfill the entire the grammatical construction of the entire sentence. So if you see here, Zidane scored a brilliant goal. So if you see here, this brilliant, even if this word brilliant is not there, this is just an adjective for this goal word, right? So here this entity that is the goal, it can still fulfill the entire complete grammatical construction of the sentence. So goal to brilliant, this is an exocentric relation. And score to Zidane, so Zidane scored a brilliant goal. So can scored itself fulfill the entire construction, grammatical construction of this sentence? So if you just take it like Zidane scored, if you go by the definition, can we get to know like whether this entity itself does it fulfill, like what does this sentence means to say grammatically? So if you see, look at this word scored. So Zidane is the subject for this. But what did Zidane score? We don't know. We need other things to specify, other entities to specify what did Zidane score. So here, this single entity, that is score, cannot completely tell the grammatical construction of this sentence. So this, in this case, is the endo. Uh, okay, just a second. I think if you look at this, Zidane scored a brilliant goal. Sorry, it should be the other way around, because if you look at it, Zidane scored a brilliant goal. So goal to brilliant, this should be endo, and score to Zidane should be exo. And the definition was still like exo can fulfill the grammatical construction and endo cannot fulfill. So if you see goal to brilliant, if we just take like goal and brilliant, can we get to know what is this brilliant goal referring to? Please forget the earlier explanation. What does this brilliant goal refer to? We cannot get to know, right? Just if we take this entity into consideration, brilliant goal, can we get to know who did what with this goal? So this goal to brilliant, we cannot know it, right? Just if you take this construction of the sentence into account, we cannot know what does it refer to, whether this just goal entity is able to specify the entire grammatical construction of the sentence. No. Why? Because here it does act like a noun and this is an adjective. But for the grammatical construction, as we saw earlier, we need verbs as well to complete. So this cannot fulfill the entire construction of this sentence. So that's why this is endo. And for scored to Zidane scored. Even if you do it like this, Zidane scored, it does give the grammatical construction that Zidane is scoring something. But what he is scoring, that is not clear. But this entity does give the complete grammatical construction of the sentence. That's why this is exocentric. And here the correct answer is option D. Is the explanation clear? Please unmute and answer. I am not able to identify whether you people are following it or not.
Yes, ma'am.
Whether you are able to follow the explanation or not, if you have any doubt, please ask right away. Let us be as interactive as possible. This will help you to solve your assignments that are being given. Every week you are to attempt the assignments based on the question. So please give them a try. So here the concept goes like this. Endo cannot fulfill the complete grammatical construction of the sentence. It can't fulfill the grammatical construction. And what do we mean by grammatical? Like your nouns, pronouns, adjectives, verbs, subjects, objects, like all these parts of the speech will come into picture. It cannot fulfill the grammatical construction of the sentence. But in case of exocentric, only a single entity is enough. So in this case, if you see Zidane's code, this entity itself completes the grammatical construction. But here, goal to brilliant, you cannot be able to identify whether this fulfills the complete construction or not. Here, this entity goal only, this is a single entity. If we take it single-handedly, it cannot fulfill. We need one or other entities in addition to goal to know whether this would be a complete sentence to fulfill the grammatical construction. So this single entity here, whether it can fulfill the grammatical construction or not, that is very important. So that you have to take care. Based on this, we solved this question and the correct answer is option D. Please give an attempt to this question. Question 3. What are the necessary conditions for dependency parsing? This is a very easy question. Here, more than one option can be correct. And this we saw in one of the lectures even. I think lecture 2 or lecture 3 of week 6 you have seen. It can be more than one option correct or it cannot be. No, I don't think it's more than one option correct. Why? Because they ask what is not a necessary condition. In the question, they ask you what is not a necessary condition for the dependency parsing. So we saw this in lecture 27 somewhere, and they mentioned 4 conditions and what are the different parsers that you can construct based on these conditions. So there they mentioned that one of the parser can work without one of these 4 mentioned conditions. So please try to attempt it on that basis. All options are necessary. Sonali, they mentioned one specific case, though they didn't go into detail regarding this. One of the although all are necessary, but there is still one parser that can work without one of these given constraints. So, what is that parser you need to tell? So, any options? Correct, Siddharth. Very correct. So, here the correct answer is option D. This is not a necessary condition for dependency parsing. Connectedness, so let us look at all these constraints one by one. Connectedness says, like, when we are constructing this dependency graph, it should not be the case that, let's say, these three nodes are connected to each other, but this is an isolated node. So this kind of condition is not allowed. This is your first property, connectedness. Acyclicity means there shouldn't be a cycle. So if this is the case, that there is this cycle that is existing between the nodes in the dependency graph that you have constructed, this should not be the case. No dependency graph can work in this scenario. And single head constraint is like, let's say we have here John saw Mary. So here, this saw is your verb, this is your subject, and this is your object. So here, what happens is, like, for this word, so this word is saw, and John is your dependent. So for John, you can have only one head. This is known as the single head constraint. You cannot have more than one head for John. And what does this projectivity says? Let's say I am deriving, this is my head I, and this is J, that is my dependent. And now this dependence again derives some another variable, okay, or some another node. So it says that when I am projecting this I, J and K on the graph, so this J and K, either they both should be on the left side or they both should be on the right side of I. It should not be the case that I is here, J is here, and K is here. So in this case, if we try to project them, let's say I was deriving J and J was deriving K, and if we try to, and this K comes somewhere here. So this J comes here and K comes here. They are aligned on the opposite sides of this I. This condition is not allowed. So that is the case of projectivity. This is an important constraint if we see the different types of the parsers in the case of labeled data, but this is not a necessary condition. There are parsers that can work without this projectivity constraints also. So this is one of the options. So here the correct answer is option D. These conditions are necessary in the case of data driven parsing. when you have the labeled data and you're creating the edges between them. But for projectivity, I think this one parser can work well. That is the constraint propagation parser. I think in that we do not need the projectivity constraint. That is not a necessary condition. So this deterministic parsing, maximum spanning tree, and constraint propagation, they are different types of the parsing generation, dependency graph generation methods. So that is the case. So now let us try to solve this one question. You have been given a maximum spanning tree and you are to tell what these are the four options, and you are to tell which of the four options can be correct, and this can be multiple option correct. So please mark the options from here, and this is the dependency graph. Just try to solve this question. This we have seen in lecture 29, and the algorithm that they use to solve this is Q-Liu-Edmonds algorithm. So you have been given a weighted directed graph, and you are to find the maximum spanning tree of this graph. So please try. Sir also discussed one example in the lecture where I think he took the example of John saw Mary. Something like that was the example that was taken in the lecture. Based on that, try to solve this question. Einstein played violin. How we can draw the spanning tree for this? In the lecture, sir took the example for John saw Mary. This is very similar to that, but here the dependency graph and the weights have been changed. Try to apply the concept. I'll give you 5 to 7 minutes to solve, and I will discuss this. Please give it a try, and once you have solved, put your answers in the chat box. So in this case, you have to apply all those constraints, like how will we construct the edges, whether we'll choose the edge of the maximum weight or the minimum weight, and in case we should not have the cyclicity condition. We discuss these conditions here. Now you have to follow all of this. A, B, and C, that connectedness should be there, and acyclicity is the main one. So while following these conditions, try to create the minimum spanning tree for this. Maximum spanning tree, sorry, for this dependency graph. So I'll give you one hint here. Since we can derive it from the name itself, maximum spanning tree, every time you create an and every time you create this try to create this spanning tree for this given graph, you are to choose the edges of the maximum weight while following the condition that cycle should not be there. And in such a case that you encounter the cycle, you contract the two nodes, and then again you apply the rules, how we can construct, how we can get rid of that cycle and derive the graph in such a way such that there is no cycle in the resultant graph. So I've given you many hints. Please just try to solve it and put your answers in the chat box. These are the options that have been given. Please give it a try, all of you. Anybody able to solve? Please put your answers in the chat box if you have solved this question. Anybody able to solve this question? I hope you have gone through lecture 29. Please unmute and answer. Are you guys solving it? Please answer yes or no. Please unmute and answer. Otherwise, I'll start the discussion. Siddharth, are you solving? Or shall I discuss? Let me know if you need more time. Unable to solve. So shall I start with the discussion then? Okay, okay. So see, here they give us this graph, and the first one of the conditions, if you remember, in case to fulfill the condition of this a cyclicity, let's say we have four nodes. How many edges I should have such that I do not get a cycle? Please be interactive, only then you can be able to understand it. Please unmute and answer. Let's say if I have n nodes, how many edges I should have such that I do not get a cycle between them. Please unmute and
n
answer.
minus 1.
n minus 1.
Yes, correct. So how many nodes do we have in this graph? How many nodes we can see in this graph?
4.
So how many edges should we be having so that we do not get a cycle?
3.
Great. So we'll be having 3. So it will be the case like, let's say I put my nodes here. Let me just erase this first. So here I'll be having my root node and Einstein. I'm denoting it by EIN, played violin. So as we know from the concept of MST I discussed with you, for whenever we are trying to link the two nodes together, we try to see what all are the incoming edges to that node. Okay, all the incoming edges we take into account, and then the incoming edge with highest weight you will choose to link that. Let's say I am having N1, N2, N3. Okay, and I have multiple edges that are like, I have two edges that are coming from N1 and N3 to N2, and this is having the weight E1, and this is having the weight W1, and this is having the weight W2. I, I will link N1 and N2 only if W1 is greater than W2. This is my condition for creating the maximum spanning tree. So going by this concept that I just discussed, I'll repeat the concept again. We will select only, we will link the two nodes, let's say N1 and N2, and we are having the directed edges here. We will link the N1 to N2 only if the incoming edge between this, for this node N2, we will select the edge with the highest weight. So if you see here, for Einstein, what all are the incoming nodes? Let me just choose a different color. So for Einstein, what all are the incoming nodes? Can you please unmute and answer? Anyone?
It's from root and violin, and also played.
Yes. So it's this one, and this one. That is denoted by A, G, and H. So which of the one is having the maximum weight here?
H.
So we will choose this one to link Einstein and violin. So you will create this H, and you will put it H to 9. Okay. Similarly, for played, you will see all the incoming edges. Can you tell which one will choose this way? I just discussed the concept. Please be quick.
It's 12, I12.
Yes, between played and violin. So between played and violin, it's I12. So, and how many notes we are having here?
4 notes.
So how many, do we create one more edge, or this is fine?
3 edges is needed.
Yeah. So let us see whether for violin, what is the incoming node? Like, what are the incoming edges? Can you tell which one should I choose in order to fulfill my MST condition?
It's F10.
C5, F10, and E4. Yes, I will choose this F10. So this is F10. This is my first step. But what was my condition for creating this dependency graph? Can I have a cycle?
No.
But do we have it here?
Yes, yes.
So what we will do, I also gave you a hint about this. What do we do here then? In case we have a cycle and also you have gone through the lecture, we will club the two nodes that are creating the cycle. Okay. Is it everyone there with me?
Yeah, fine, ma'am.
Yes, ma'am.
Yeah, okay. So we will club these two nodes, and for this now we will denote the combined node as, let's say, PV. Okay, played and violin. Okay. Just a second. I'll add another slide so that it's easier to explain. So now what I will do is, Now I need to again recalculate. So first of all, I'll draw my notes. Just a second. This is root. This is Einstein, plate, and violin. So since I was to club these two together, let's say I have clubbed these. How many edges should I now be having so that I do not have a cycle? Consider this as one node only. Or maybe for your better understanding, I will put it like this. Let's say the root is there, Einstein is there, and PV is this node. So in case I have three nodes, how many edges should I have so that I do not get a cycle again?
2.
Okay, great. So now, whenever I am creating this new node, combined node, what I will do in this case, how do I define the incoming and the outgoing edges for this node? That is one important concept that you need to look into. Like, how will I define the incoming and the outgoing edge for this clubbed node, that is PV? This is very simple. Like outgoing is like the edge that is going out, and incoming is like the edges that are coming to this PV. Only for this we need to calculate. Okay, so in this case what I will do, for incoming I will consider incoming to PV. I will consider all the ways in which I can reach plate to violin. So for this we will go to our original graph. So plate and violin. In this case, I will select like what all are the edges that are coming. Let's see. Let's say this your plate and violin is your new node. Okay. So now here, where you will see like the edges that are coming for root to plate or root to violin, which one of them is having the maximum weight, that you can choose. So for this, you can have the paths like this. For the incoming, you can have the paths like this. Since you need to link root to PV, that is one way you can reach, and Einstein to PV is another way you can create the incoming edge. So let's say we will consider these two paths. I reach from root to plate to violin, or I can also choose this one, root to violin to plate. Now let us go and see which path gives me the maximum weight. So root to plate to violin or root to violin to plate, we are taking this path. Okay, I'll just highlight it. We are, as of now we are looking into this part of the graph. So root to plate to violin, if I take, that would be B3 and F10. That would be how much? Root to plate to violin, what is the
13.
weight of this path?
13.
And root to violin to plate?
5 plus 12, 17.
Yes, that is 5 plus 12 equals to 17. Which one do I choose?
Root to violin to plate.
Great. So we will choose this path, root to plate to violin. And here I will just mark it as 17. I hope you have understood. And for similarly, we can choose it like this as well. If you consider the remainder part of the graph, that goes like this. Either you can choose Einstein to plate to violin or Einstein to violin to plate. So if we choose like this, Einstein to plate to violin, what is the weight? Tell
15.
speaker.
15.
And Einstein to violin to plate, is there any such path? There is E4 and this 12, I12.
Yeah.
Einstein to violin to plate. है ना? So this is 4 and 12.
16.
That is 16. So out of these two, which I choose?
Einstein to violin to plate.
Yes, great. Einstein to violin to plate. This is another incoming edge, 16. And we know from the condition of the maximum spanning tree, I will only choose what? The incoming edge with the maximum weight, highest weight. So here what do I choose? 16 or 17?
17.
Great, great. I'm glad that you are there. Now we are to choose the outgoing edge from this constructed node. So for the outgoing edge, how you will choose? For the incoming, we chose all the edges that were there in this path, right? We saw the path, how it could traverse from Einstein to violin to plate or violin to plate to Einstein and all that things we considered. But for the outgoing edge, how you will consider, like whether the edge that is outgoing from plate to Einstein is having the maximum weight or violin to Einstein is having the maximum weight. In this case, you will not consider all the incoming edges inside the path. The condition is different for the outgoing. So outgoing you will choose whether plate to Einstein is having the maximum weight or violin to Einstein is having the maximum weight. So let us go and see. So plate to Einstein, what is the weight that it is having?
7.
7, yes. And then violin to Einstein, what is the weight we are having?
9.
So what do we choose in this case?
9.
Just violin to Einstein was 9 and plate to Einstein was
7.
7. This is one outgoing edge. So this we have discarded. This we will take into account 17 and 9. Okay, sorry, this we have chosen. So now your graph reduces to this. It becomes like root Einstein and plate violin. So this became as 17 and this became as 9. Okay, but we cannot stop here. We have to again break it down and see, though it fulfills that condition that the graph is connected, it is acyclic. And what was the third condition? We had 4 conditions. No, projectivity is not always necessary. What was the third condition? If you remember, in this, single head should be there for every node. That condition is also being fulfilled. All are dependent on this. Okay. So here if we break down it into further nodes so as to see whether for my contracted node I created so that I could choose the edges with the maximum weight and I don't have a cycle. So let's see if we break it down, how does it, is it still valid or what? So we know in this case that for plate to violin or Einstein to violin, what edge was, what node was giving me the weight 9, if you remember? Which one was giving me the weight? Here 9. Plate or violin? Hello? Am I audible? Violin, yes. Please unmute and speak. So here, violin to Einstein was giving me the weight as 9. Violin to Einstein was giving me the weight as 9. And we know what path we chose that gave me the weight as 17. Root to plate to violin or root to violin to plate. So if you see here, root to violin to plate gave me the weight as 17. So I will put that here. root to violin to played. That gave me the weight like 12, 5 and this. So are we having any cycle here? This is your resultant graph. So are we having any cycle in this case?
No.
Is the graph connected?
Yes.
So this is your resultant dependency graph. Is it clear how we will find? And what is the weight of this graph? Maximum spanning tree weight?
26.
Yes, great. So 12 plus 5 plus 9, 26. Coming here to the options. Do we have the weight as 26? Yes. And is there an edge? It says it does not contain an edge between Einstein and plate. So this is our resultant graph. Do we have an edge between Einstein and plate?
No. No edge.
There is this edge from violin to Einstein. I'm sorry if because of this you might be having a doubt, but there is no edge between Einstein and plate. So this option is also correct. And MSTG, this says 5, 12 and 7. Is it like going in this order? 5, 12 and 7? No, right? If even if you have add the weights, you will be able to identify that this does not add up to 26, right?
No.
And it says F belongs to MST of G. Are we having this F as F equals to 10 in our resultant MST graph?
No.
So this option is also not valid. So here your answer is option A and C. I hope this is clear to all. This was a good question. You can expect questions like this in your exam as well as your assignment that you will be solving this week. So I hope it is clear to all. How did we did the first step, and what were the conditions we applied when we were contracting the two nodes, and why did we contract the two nodes? Why? Because we were facing a cycle. Then there is this different condition for the incoming and the outgoing edge that we did, and again after contracting we again unclubbed those nodes and saw whether it gave me a cycle or whether did it fulfill the dependency graph conditions or not. And then we computed the weights and marked the correct options. So I hope it is clear to everyone. In case there is any doubt, please let me know. Any doubt, anyone, in this question? Okay, great. So, great. So that's it for today. I hope now you will be able to solve the questions related to the concepts that I have discussed. In case you have any doubts, please feel free to write at this email address. And also I will be uploading today's discussion video on this channel. This is my YouTube channel link, so you can refer to here in case you have any doubts or you missed any concept, you need to refer to it again. So that's all for today. Thank you everyone for attending. I hope these sessions help you. Thank you.